Hello everyone, welcome to the next video on analog and digital electronics, that is digital memories. Myself Naina and Ganesh Jadhav presents you Introduction to Digital Memories. We are from Kekewag Institute of Engineering, Education and Research, Nasik. The outline of the today's session is learning outcomes, introduction, types of digital memories, primary and secondary computer memories, RAM and ROM, differentiation between RAM and ROM memories, introduction to SRAM, DRAM, and summary. The learning outcome of this session are, at the end of this session, student will be able to explain and differentiate primary and secondary computer memories. Explain primary memories, RAM and ROM. Differentiate between RAM and ROM memories and simply explain SRAM and DRAM. Okay? So memory is a great gift given by the God. As we know, from childhood to our younger one, we can recall many things in our old days. Some things we recall instantly, but some things we may not, because our memory has two parts, short-term memory and long-term memory. In short-term memory, we can recall the things instantly. Okay, some things in our mind, in the memory, remains forever. Okay, so similarly, the computer without memory, we cannot imagine whatever data, whatever information, whatever programs we have done, we have to store at some place. Okay, like our home, in our home we can put the things at some proper place. That place is nothing but what? Memory to keep that device. Okay, so let us discuss the digital memories. All of us studied complex mathematical and scientific concepts, and we crammed our brains with detailed accounts of historical facts and figures. We even put our knowledge on our sheets during the exams, answer sheets. The amount of information our brain can accept and store is fantastic. Our brain can store many things. We can recall, we write, we read, we memorize. Okay. Similarly, there is a concept of digital memories in the world of computers that helps them to store the data. In computers, memory is most essential component for the normal functioning of any system, to store data, to perform calculations, to do complex operations, etc. We know that almost all our information and data is stored in hard disks within the CPU. The hard drive disk, hard disk hard disk drives has the most expensive memory in a computer system, but a lot of important data of computing devices is stored in what we will say is in the primary memory. Okay, so let us discuss memories and its types. So, a memory is an important component of CPU, that is important part of the computer. It is used to store data and programs. There are two basic memories in a computer, primary memory and secondary memory. So, memories are divided in two parts. First is primary memory and second is secondary memory. Again, primary memory and secondary memories are divided. Primary memory, there are two types, RAM and ROM. RAM is again divided in two parts, SRAM and DRAM, whereas ROM is divided in PROM, EPROM and EEPROM. So primary memory has these types, whereas secondary memories are nothing but what? External memories of the computer, which are HDD, SSD, compact disk, floppy disk, and magnetic tape. So let us discuss first primary memory. Primary memory is that memory that a processor accesses directly. Data is temporarily stored in primary memory. Primary memory is lost when computer power off. The primary memory is located close to the central processing unit on the motherboard. It is near the CPU. CPU access information immediately from the primary memory. It gets the information as and when required immediately. Okay, so it is near the CPU. The processor thus gets an immediate response to any information needed without much delay. Hmm? The information we can get and we can access is fast in case of primary memories because it is near the CPU. It is expensive, but it is very fast. Okay, there are two types of primary memories: RAM memory and ROM memory. Again, RAM memory is divided in two types, that is SRAM and DRAM, whereas ROM memory is divided in PROM, EPROM, and EEPROM. Okay. Let us discuss what is secondary memory. Secondary memory is nothing but what external memory used to store the data, and that's why secondary memory is called as what storage. Secondary memory is called as what storage. Secondary memory is the memory where program and data stored permanently. That data can be stored permanently in secondary memory. Secondary memory is a non-volatile memory which does not lost with loss of power. The secondary memory is physically located within a distinct storage device such as HDD, that is hard disk drive, USB, CD, DVDs, etc. So secondary memory is a storage. We can store the data permanently. It is a non-volatile memory. Okay. The next we will see RAM. RAM is a random access memory. Random access memory means what? It is a type of volatile memory that stores and retrieves or recalls the information on a computer instantly. Information on the RAM can be accessed without any predetermined order. There is no specific order of the information which we get from the RAM, and that's why it is called as what? Randomly access memory or random access memory, and that's why its name is RAM, random access memory. Random access memory is a semiconductor device placed on a processor that stores variable for CPU calculations. RAM provides memory locations for requested data, that is registers. The CPU receives a data read instructions with the data's memory address or locations. There are two types of RAM, SRAM and DRAM, that is static random access memory and dynamic random access memory. So before studying SRAM and DRAM, let us have a look on ROM. Let us have a look on what? ROM. So what is ROM? ROM is a read-only memory. Okay, read-only memory. It is type of non-volatile memory. ROM is what? Non-volatile memory. That means storing and recalling or retrieving the information on a computer. As the name goes, this type of memory allows memory to be read-only. Since it is a non-volatile, it does not require a constant power supply to retain the data stored in it. Okay, that means no continuous power supply is required to store the data. ROM is read-only memory and cannot have the data altered easily. In case of random access memory, we can change the data, we can alter the data easily, but that is not in the case of ROM. We can read the data only in ROM. There are different types of ROM. The types of ROM are first PROM, EPROM, and EEPROM that we will discuss later. Okay. So let us differentiate between RAM and ROM memories. The parameters are given here, and according to parameter, we will differentiate between RAM and ROM. Let us first see the first parameter, that is data retention. RAM is a volatile memory. RAM is what? Volatile memory, which could store the data as long as the power is supplied. Okay, but that is not in the case of what? ROM. ROM is a non-volatile memory which could retain the data even when power is turned off. Okay. The second parameter is working type. In RAM, data can be altered or retrieved or accessed again. Whereas in case of ROM, data is stored only. It cannot be write. Okay, we can read the data only. We cannot alter the data in ROM memory. Third, use. Used to store the data that has to be currently processed by the CPU temporarily. That is, RAM is used to store the data temporarily. But that is not in the case of ROM. ROM stores the instructions required during bootstrap of the computer. Okay, whatever program, whatever functions we are performing in a computer, that can be stored permanently in the ROM. Next parameter is speed. RAM are having high speed memories, whereas ROM are much slower than RAM. The speed of ROM is slower than the RAM. CPU interaction. The CPU can access the data stored on it because RAM is placed near the CPU. But in ROM, the CPU cannot access the data stored on it unless the data is stored in RAM. The size of RAM is large with higher capacity, whereas the size of ROM is small and having less capacity. RAM is used in CPU cache or primary memory, whereas ROM is used in firmware or microcontrollers, etc. RAM can stored and easily accessible, that is accessibility. RAM data or RAM information is accessible easily, whereas the data stored in a ROM cannot be easily accessible as it is in the RAM. Okay, and the last and much more important point is what cost. RAM is costlier, whereas ROM is cheaper. Okay, ROM is cheaper than RAM. So these are the important points to be remember whenever you differentiate between RAM and ROM. The important parameters are data retention, working type, use, speed, CPU interaction, size and capacity, use, is accessibility, and cost. Okay, so these are the important points. So whenever you differentiate between RAM and ROM, let us discuss next types of RAM. A typical computer usually has 8 gigabytes of RAM. We can increase or we can boost this up to 64 GBs in the newer systems. If you are using programs and software which take up a lot of space, for example, Adobe Reader, Photoshop, etc., you might need a more significant RAM memories. Whereas, if you are having sufficient memory but lot of programs running at the same time, it might slow down the memory fetching operations of the RAM. Okay, so let us discuss the types of RAM. There are two types of RAM, SRAM and DRAM. SRAM, that is static random access memory. It is a memory chip that is faster and uses less power than DRAM. Static RAM is a random access memory that retains information as long as power is provided to the SRAM. It does not have to be periodically refreshed. Okay. Why the name of this SRAM is static random access memory? Why it is called SRAM, static random access memory? This is because the data is held statically without any need of refreshing. There is no need to refresh the data. That is, the information in the memory is retained in the memory as long as power is supplied. The SRAM gives quicker access and data and is more expensive than the next type of RAM that we are going to discuss in next part. So next part of the next type of the RAM is what? DRAM. So before going to DRAM, let us see what are the applications of SRAM. SRAM is having high speed. So due to its high speed operation, SRAM is used for cache memory, and as a part of the digital to analog converter, it is used in video cards. Okay, it is used in cache memories. In case of analog to digital to analog converter on video cards, it is also found in CDs, printers, routers, DVDs, and digital cameras. So these are the applications of what? SRAM. Let us discuss DRAM. DRAM is a memory chip that can hold more data than a SRAM chip, but it requires more power. It requires what? More power than case of SRAM. It is termed as dynamic It is called as what? Dynamic. Why it is called dynamic? Because the system needs to be activated frequently. The system needs to be refreshed or made dynamic so that it doesn't lose its information. And that's why the name of this random access memory is dynamic random access memory. Okay. What are the applications of DRAM? DRAM. The DRAM is a main memory in computers. It is a main memory in computers and graphic cards. It is also used in many portable devices and video game consoles. So it is an important memory in computer. There are three types of DRAM: synchronous DRAM, rambus DRAM, and double data rate SDRAM that we will going to discuss in another sessions. So in this session, what we studied? In this session, we have studied that what is a digital memory. We have studied the types of memories, that is primary and secondary memory. Primary memory it is near the CPU. It is a temporary memory, whereas secondary memory is an external memory. We can store the data permanently. Then the third, we have seen primary memories, that is types of RAM and ROM. RAM is a random access memory, it is a volatile memory, and ROM is a read-only memory, it is a non-volatile memory. Also, we have differentiated between RAM and ROM on some parameters. In RAM, we have seen the just introduction of SRAM and DRAM with its applications. So, in next session, we will see or we will study in detail SRAM and DRAM memories. So, hope you understood the types of digital memories or introduction to the memories. Till then, thank you.